I'm Glen Kissel with the Department of Engineering at the University of Southern Indiana, and my talk today is Unite, USIP's first CubeSat, what went right, what went wrong. On January 31st, 2019, the University of Southern Indiana Unite CubeSat was deployed from the International Space Station and went operational 55 minutes later when it phoned home through the Globalstar satellite network. In fact, the Unite CubeSat was the first of the 23 CubeSat projects funded by NASA's Undergraduate Student Instrument Project, USIP, to achieve orbit. In this presentation, I will look at what has gone right and what has gone wrong since the inception of this project in late August 2016, over 3.5 years ago. First, some background. Unite, Undergraduate Nano-Ionospheric Temperature Explorer, is a 3U CubeSat with 3 missions. First, measure plasma properties in the lower ionosphere using a Langmuir plasma probe. Second, measure the CubeSat's on-orbit temperature at 8 locations on and inside Unite to be used to update a student-developed thermal model. And third, carefully track decay near reentry to improve drag models in that regime. NASA USIP required the team to be undergraduate students only, that the team be multidisciplinary, and that flight hardware be ready 18 months after project inception. NASA Wallops Flight Facility was the project manager, and the Indiana-based Near Space Launch, NSL, was Unite's prime vendor. The University of Southern Indiana is an undergraduate teaching institution that has had an engineering program since 2002. It has no aerospace engineering degree, so there was no natural constituency from which to draw a CubeSat team. Nevertheless, I was able to recruit 10 students that carried the project through the first 16 months, including the critical design review and an initial integration. The next 13 months, which included environmental tests, vibration, final integration and testing, delivery and deployment, had only 5 active members, most of whom had been part of the original 10-member team. I had been advised by University CubeSat veterans in 2016 to avoid recruiting too large a team, as many would end up not being willing to make the work commitment. But were 10 and then 5 team members too few? Well, the small number meant a cohesive group that worked well together and helped each other when problems happened, and their project has been working in orbit for over a year. On the other hand, when we had to do a late deintegration to remove some debris, it was discovered that there was insufficient documentation and photos of the original integration process. Also, coding was dependent really on one person. Only a few temperature sensors were fully calibrated in the flight unit, and a GPS problem was discovered very late in the process, shortly before delivery. I would say that 5 more members during the first phase, and maybe 3 more during the second phase, would have helped avoid these issues. So what went right? A cohesive, motivated group of students successfully delivered and has operated a CubeSat. What went wrong? Understaffing, I believe, led to avoidable problems. The Unite CubeSat is quite simple. It has few bells and whistles. It has no deployables. Early in the design phase, the students had been urged by the vendor to include deployable solar panels for more power and increased drag. The students declined this option. Students kept it simple, and this is consistent with advice from many quarters. Remembering that NASA wanted flight hardware ready in 18 months, and given Unite was the university's first CubeSat and the team size was small, this appears to have been a wise decision. UNITE was the first USIP CubeSat deployed, and NASA acknowledged to us that they valued this timely deployment. On the other hand, UNITE ended up being deployed above 400 kilometers. Ideally, 325 kilometers would have been best, and deployment was at solar minimum. So the orbital decay rate has been painstakingly slow, and it will be a year or more before UNITE reaches an altitude where it aerodynamically stabilizes in the RAM direction, allowing proper plasma probe data taking. What went right? UNITE was kept simple, allowing timely delivery and deployment. Foregoing, though, deployable solar arrays will mean a long mission, risking CubeSat malfunction before the main data taking can be accomplished. UNITE's thermal vacuum test, TVAC, occurred over 3 days at Morehead State University in Morehead, Kentucky. I found that there was no standard advice about how to conduct such testing. Some advised simply to put the CubeSat through the thermal vac cycles after bake-out, and then test it afterward to make sure it worked. Rather, we followed the advice from the University of Illinois Urbana-Champaign to turn the CubeSat on and off multiple times during the TVAC cycling. Now, because of a miscommunication with Morehead State University's Spacecraft Environmental Testing Laboratory, that laboratory did not have liquid nitrogen on hand for our TVAC tests. The CubeSat was only cycled to high on-orbit temperatures, but not to expected low on-orbit temperatures. Nevertheless, the UNITE CubeSat has performed well on orbit at all temperatures. So what went right? Well, TVAC testing was executed, including turning the CubeSat on and off during TVAC cycling. What went wrong? As a result of a miscommunication, it was never tested at low on-orbit temperatures. From the beginning, UNITE has had the Globalstar-based Simplex and Duplex as the basis for its communication subsystem. In other words, UNITE does not have a ground station. Communication with UNITE began 55 minutes after deployment, and data has successfully been received at all times of day and all points in an orbit. This has allowed the team to gain quick insight and then continuing insight as to the status of the vehicle, and this is a real boost to student confidence and learning during orbital operations. However, every bit of Simplex data does incur a cost, and if data rates are not carefully regulated, Simplex data can become a financial burden. If data could be sent through the duplex, data costs would come down substantially. Unfortunately, the CubeSat must be very stable to allow a duplex data connection to be made. In this vein, the vendor recommended we install small magnets in addition to mu metal rods on UNITE to help slow the CubeSat spin rate. The rates did slow substantially by the 4th month in orbit, but we have yet to receive any data via duplex after 15 months in space. Commanding via duplex does not require quite the same level of CubeSat stability, and UNITE has successfully received commands. However, it can take 1 to 5 days for them to be received once they are transmitted on the ground. It should also be noted that the addition of the magnets has in part ruined one of the axes of our onboard magnetometer. What went right? Simplex communication gives a reliable and continuous stream of data. No ground antenna is needed. What went wrong? Simplex data is costly and duplex communications have been problematic. This being the University of Southern Indiana's first CubeSat and not having an aerospace engineering program, we had minimal facilities in which to conduct the CubeSat project. However, the team gravitated to 2 facilities on campus which proved excellent for their work. Our adjoining optics lab and optics classroom became the central location for the project. The classroom, shown in an earlier slide, was our team meeting area, and the adjoining optics lab provided excellent bench space, shown here, for engineering design unit work. We were in need of a clean flow hood for the project, and fortunately, a senior design team, not part of the UNITE project, designed and built a clean flow hood for us. This became our central integration and test location for UNITE flight hardware. The second on-campus facility was our engineering department's printed circuit board lab. There, a number of prototypes of our command board were created, and the final flight command board, fabricated by Sunstone Circuits, was populated by the students in the PCB Lab. The solar cells were also integrated onto solar panels in the same lab. See the references at the end for a discussion of that integration and many other lessons learned. We do not have TVAC, VIBE, or other test facilities at the University of Southern Indiana. As I mentioned, TVAC was done at Morehead State University. The University of Illinois Urbana-Champaign very kindly offered their test facilities to us at no expense, and I have Dr. Alex Ghosh to thank for this. Consistent with that lab schedule, we did CG test, mass moment of inertia testing, Helmholtz cage magnetic field test of the magnetometer, shown here, solar simulation test of the solar panels, and bake out of the solar arrays. In addition, we received great advice from Dr. Ghosh and great help from his students during these tests. Dr. Ghosh also directed us to a company in Indianapolis, Engineered Testing Systems, that conducted our vibration test at no charge. What went right? We were able to use existing facilities at the University of Southern Indiana to complete the project, and the University of Illinois Urbana-Champaign kindly offered their test facilities and student help and advice. Nothing went wrong in particular, it just testing had to be consistent with the University of Illinois' lab when we wanted to go up there. Finally, I want to mention the great support we received from NASA's Launch Services Program and from our deployer, NanoRacks. They were consistently professional and patiently worked with us even as vexing problems reared their heads. They were a big part of what went right with this project. I conclude by noting some UNITE distinctives. UNITE is the University of Southern Indiana's first spacecraft. UNITE is in fact the first spacecraft produced and flown by a public institution in the state of Indiana. And UNITE is the first NASA USIP CubeSat deployed in orbit. I hope this presentation has been helpful to you and will be of use to future CubeSat teams.